This is lesson number 2, and I will be talking about types of chemical reactions. Today's objective is that you will know the 5 types of chemical reactions and that you will be able to classify any chemical equation as one of the 5 types. And you should be able to do that with 85% accuracy. That's the goal. So there are 5 types of chemical reactions. We have synthesis, decomposition, single replacement, double replacement, and combustion. So let's go ahead and take a closer look at each one of these. In a synthesis reaction, we have something that looks like this. Here we have hydrogen plus oxygen gives water. This is an element and this is an element, and they combine together to form water. This is also known as a combination reaction. These twos you see down here, they, if you recall from previous lessons, need a 2 because these are 2 of the diatomic elements. Remember the 7 diatomic elements, Brinkelhoff, are H, N, O, F, Cl, Br, and I. When hydrogen and oxygen are by themselves, they need a 2 beside them. So diatomic molecules are those atoms that are found in pairs. And what's unique about a synthesis reaction is that there's only one product. In a decomposition reaction, which is pretty much the reverse of synthesis, so I'm going to use the same equation as before, I'm going to use this equation, but we're going to flip it. So now we have water becoming hydrogen gas and oxygen gas. So we see water breaking apart into 2 different elements. What's unique about this is that there's only one reactant. So we only have one compound or molecule on the left side of the equation. In a single replacement reaction, we would have something that looks like this. So we have here with aluminum an element and here a compound. Now, the element, aluminum, the metal by itself, is going to replace this copper that is part of the compound. So when we look over here, we'll now see copper is alone and aluminum is now bonded to chlorine. So these 2 elements have simply swapped places. And now we have one new element that is alone. Don't forget that at the end, we have to use subscripts, not because this Cl is diatomic, but because we needed it to balance out copper 2 chloride. And it's the same here. That's why we see a 3 on the other side. In a double replacement reaction, we would have something that looks more like this, where we have a compound plus another compound, giving 2 new compounds. So here we're going to pay attention to the first 2 elements. Again, we're going to pay attention to the metals, the aluminum and the copper. Now, in a double replacement reaction, these are going to swap places. But on the product side, we're not going to have any element by itself. We're going to form 2 new compounds. So you'll see that the aluminum is now with the chlorine and the copper is now with the sulfate. Again, you always have to remember to balance out your charges and add subscripts where necessary. Okay. A neutralization reaction is just a type of double replacement reaction. And in a neutralization reaction, we would have an equation that looks more like this. So we still have a compound plus a compound giving 2 more compounds, where we see the Ca and the H have swapped places. But this is unique in that we have an acid plus a base, and an acid is something that is characterized by hydrogen. So it should begin with an H, whereas a base should end with an OH. It should have this OH group attached, the hydroxide group. On the other side, we're going to produce a salt and water. We're very familiar with what water looks like, but what exactly is a salt? A salt is just any compound containing a positive and negatively charged ion. So the calcium has a positive charge and the chloride has a negative charge. That's a salt. And I know you've all experienced fire before, so let's talk about combustion. In combustion, we have a general equation that looks like this. This first part is called a hydrocarbon. This is oxygen gas. Remember, oxygen gas has to be O2 because it's one of the diatomic elements. And it will always produce carbon dioxide and water. Now, a hydrocarbon consists of a carbon atom and a hydrogen atom, but I put an X and a Y here because the numbers can vary. So if we want to be a little more specific, I'm going to give you 3 different combustion reactions. So these are all types of combustion: a hydrocarbon plus oxygen, hydrocarbon plus oxygen, hydrocarbon plus oxygen. And I want you to notice a few things. Number 1 is that the ending parts are the same even if the numbers in the front are different. So the coefficients are different, but the compounds themselves are the same: O2, CO2, and H2O. So O2 is always going to be the second reactant in a combustion reaction. And on the product side, you're always going to see CO2 and H2O as products, not just one. They must both be present for this to be combustion. And finally, let's classify a few by ourselves. So here we see that we have some compound that turns into 3 more compounds. Well, 1 element and 2 more compounds. So this is broken apart into 3 different things. Our clue, though, is that this first part only contains 1 reactant, so this has to be decomposition. In this second one, we have 2 reactants that are forming a single product, and if you'll recall from earlier in this lesson, if there is only 1 product, it is synthesis. And finally, if I'm looking down here, I have Cl2, which is an element, plus a compound, giving a compound plus a different element. Well, an element plus a compound, where 2 things swap places, so in this case, the Cl and the I have swapped places, and now the I is alone, and the Cl is with aluminum. So this would be single replacement. So now you should know the 5 types of chemical reactions, and you should have the ability to classify any chemical equation as either synthesis, decomposition, single replacement, double replacement, or combustion with 85% accuracy. Thank y'all for watching.